Swayam Prabha. Digital India. Educated India.
Hello everyone. So, we are discussing the factors affecting the cut resistance. So, a fabric for a particular fabric we can change the cut resistance by changing some parameters. Okay. And understanding these parameters is very important for actually getting better protection. These factors are blade geometry and angle of attack that we have already mentioned, normal force, then cutting speed, whether it is a slow quasi static or rapid dynamic slash, and now we will start another factor which is fiber orientation and fabric structure. So, yarn is made of number of fibers, okay. And the fiber, that is as a polymer, if we suppose we are using a high performance fiber, but that fiber if we orient at different direction, we can manipulate the cut resistant characteristics. Even in the yarn, we can manipulate in different structures like core sheath structure, and all are different direction we can get. So, stainless steel or glass core we can use, different types of alignment we can use depending on our requirement, either parallel alignment or random alignment. So, all this process, all these actually factors in the yarn will affect the cut resistant property. Similarly, twist level of the yarn, number of plies like 2 ply, 3 ply, multiply yarn, core sheath structure. So, if we use metal core and high performance sheath, fiber in sheath. So, that by doing this we can manipulate the cut resistance, and also in weaving we can change the density, yarn density, thread density, ends per inch, peaks per inch we can change, and we can also change the structure, whether pattern like plain weave, twill weave. Similarly, in knitting we can have warp knitting, weft knitting, we can change the loop height, okay, stitch length, stitch, that is loop density we can change. So, that also affect the cut resistance, and also in braiding we can dense or tight braiding we can have for higher cut resistance. So, for producing the cut resistant textile, we can manipulate all this, like starting from fiber, yarn structure, type of fabric, density. So, everything can be changed to get optimum cut resistance. The alignment of fibers in the yarn and yarns in the fabric and different textile architecture So, all this we can change, backing material we can change, and so apart from this backing material also affect the cut resistance, and pre-tension. So, if we use some backing material, that will give additional support. So, it is described how the material is supported or tensioned during the cutting. If we have high tension, then the cutting may be sometime easier than the if the yarn is the fabric is in lower tension. So, that if we change the tension, then cutting effect will be different. So, each of these can alter the energy required to cut through the textile material. So, effectively it is a energy required to cut through. So, that earlier you have discussed the energy balance, force balance. So, here by manipulating this we can alter the energy required. Now, we will discuss one by one. So, first is the blade angle of attack and cut mode. So, cutting modes are basically, one is slicing or by pressing. Slicing means by simply getting the shearing action. So, a blade can cut by pure pressure, perpendicular pressure, where the sharp blade will have the contact area, low contact area. That is why for a certain load, the sharp knife will cut a thing, any material easily than a blunt knife. That is, the cutting is by pressure, apply pure pressure is there, or by slicing at an angle. Then angle of attack, that is inclined blade or slicing motion, that is angle of attack, that significantly reduce the cutting force or energy needed to cut. Like if we have some slicing force, slicing motion is there, or if the angle of attack is different, inclined attack is there, then significantly reduces the force or energy required to cut. So, here this is the load, here it is a the cutting is that, and we can have at certain angle. So, this is pressing, and here is by slicing, or here is by slicing. So, if there is a certain angle, so that inclined blade, and if there is a movement, then there will be a slicing force. A more inclined edge creates slicing action, concentrating the shearing along the fiber and often initiate cut more easily. So, if you have more inclined angle, and if we slice it, there if we have slicing action, then the material will cut more easily. Now, blade geometry. The sharper blade or more or one with lower edge angle cuts easier. So, sharper blade definitely we will cut easier, that we have already discussed, due to the lower contact area. So, standard tests fix the blade specs. So, blade specification is fixed there, but real blade that may vary. That is what we have already mentioned. So, real knife may be entirely different from the standard knife or blade we use during cut test. So, serrated type of blade behaves entirely differently. So, however, within the given test, the angle at which the blade meets the material plays a role. So, angle of attack is important. Now, this is the front view, here is the side view of the blade. And we can see here there is a angle theta 1, theta 2, theta 3. So, here angles are different here. Now, angle of attack, if we are saying, or cut mode of cut, like TDM and coupe method. So, their mode of cuts are entirely different, because in TDM the straight blade moves to and fro, but in coupe method it is a rotating, it is high speed. In coupe test, blades both rotates and slides, provide a shear angle. This contributes to its cutting efficiency per cycle. Okay. And in TDM method, the blade moves across at 90 degree to the cutting direction. Cutting direction is say vertical and blade moves at 90 degree, and here there is no deliberate slicing angle is created. Okay. Although the blade is straight edged. This difference means the mode of cutting in the test can influence the result. So, that is why we have to specify the which method is used to cut the test. Okay. Although their test methods are different, their interpretations are different, and the design implications are the cut resistance cloth might protect better against one mode than another mode. That is important. So, a particular cloth, if you test in TDM method or once you test in the other method, that may perform differently, same cloth. So, materials that resist the straight stab may still be vulnerable to the draw slice or vice versa. So, that may not be sufficient. So, a good material for straight stab may fail during the draw slice. So, type of attack, angle of attack or cut mode is very important. Testing at multiple blade angle can give a full picture of protection. So, in testing, in normal testing, what we do in particular angle, straight angle, but if we test in multiple angle, blade angle, that will give us the complete picture. So, after blade angle and the cutting mode, next factor is that normal force or pressure effect. So, force drives the cutting. So, if we increase the force, the cutting will be easier. So, higher the normal force, the downward pressures make the cutting easier. So, at higher force, normal force, shorter distance will be required or fewer strokes will be required to cut through. That we have discussed in while discussing the standard. Here we can see as we increase the normal load, so cut through distance are reducing. So, while testing, in normal testing we use certain cut through distance or certain load, but in actual practice this may be entirely different. So, we must have clear idea that how this cutting performance is affected by normal force. In TDM test, as the load increases, the required cut distance falls at a higher rate initially, then there will be little bit slower rate, but still there will be fall. So, that is essentially the cut resistance is inversely related to the applied force. So, doubling the force does not double the required cut length. Instead, the cut through happens much sooner. Then the critical force threshold. So, in case of normal force, so there will be critical threshold force will be there. There is often a threshold force below which the material will not cut through at all. So, that we must understand. So, the blade just indent and or its glance off, there will not be any cut although blade is moving. So, we must also understand that there is a critical threshold force. So, that force is very important in designing the cloth. Whatever we design, we must have the critical force, threshold force. So, that our cutting should, that fabric should not get cut at particular the force, whatever probable force will come in any activity, that should be below the critical threshold point. That is the idea. So, once above that threshold, the incremental force rapidly improves the cutting. Okay. So, above that threshold point, no cutting force within the blade edge, so that within the blade edge length of 65 millimeter. So, that is the 65 millimeter if you see. So, unit pressure, the concept of pressure, the force per blade area also matters. A given force on a thinner blade, that is sharper blade, exert high pressure, okay, cutting more effectively. So, what type of blade we are handling with? So, for a given force, if the sharper blades we are using, that will cut easily, effective cutting will be there, cutting will be there. The standard blades have a fixed geometry. So, pressure scale scales with the force, okay, because if we use the standard blade, that tip will have fixed geometry, that means the cross sectional area of the blade tip will be fixed. So, here as we increase the force, the pressure will increase. So, that is why consistent test load is applied in coupe test, fixed load is there at 5 Newton. So, that fixed pressure we apply, but this might not reflect the worst case real force, because in real force that may be much higher than this, and there the cut resistance, the fabric will get cut through quickly. Next factor which we have mentioned earlier, that is a fiber orientation and fabric structure, which is very important. So, fiber orientation and fabric structures are very important. The orientations are basically textiles are anisotropic, that is the cut resistance varies with the angle of cut relative to the fiber and yarn direction, that is very important. Now, if we see, these are the fiber orientation. Okay. Now, if our cutting distance, cutting through is in this direction, if the blade cutting is in this direction along the orientation of the fiber, then it will be difficult to cut, because the area will be very high, area of obstruction. But if the direction of cut is in normal direction, this is the direction of cut, then the cutting will be easier. So, fiber and yarn direction is very important with respect to the cutting direction. So, cutting along the fiber bundle can be harder, it will be difficult when the blades must shiver a strong fiber along its length. So, this is the stronger fiber. If the cutting direction is along the fiber bundle, then it will be very difficult to cut, as compared to cutting across the fiber or at bias across the fiber, where the effectively cutting thinner cross section it is cutting, and fewer fibers are cutting at once. So, this will be easier, here it will be difficult. So, orientation of fibers are very important. So, standard practice is the test of woven fabric at 45° angle, biased angle, to average out warp and weft directional effect. So, this is true for warp and weft direction. So, what in case of woven fabric we use at certain angle, that is standard angle is 45°. Then yarn mobility. So, fabric structure, we can have certain fabric structure where the yarns are loose, like open structure, or maybe weave we can change, like satin and plain. In plain weave we have number of interlacements are very high, but in satin due to the floats number of interlacements are low. So, yarn mobility in case of satin will be high, higher than plain woven fabric. So, due to this yarn movement, so distortion of threads taking place, and that will take extra energy, additional energy. So, effectively the cut resistance will be high there. So, if fibers can slip away from the blade, they may avoid cutting. There is a loose structure, yarn mobility. A loose fabric structure, the more mobility can sometimes show higher cut resistance due to the yarn movement, yarn sliding instead of breaking. So, there is some hypothesis, loose structure give higher resistance than tight structure, because in tight structure thread cannot move, cannot slide. So, a particular thread will be loaded at a time. So, that will cut immediately. So, however, studies have contradicted this also. So, loose structure sometimes, this is the one hypothesis, but the studies says that loose structure gives a lower cut resistance. A plain tight weave outperform loose twill weave in cut test. So, that is why it is recommended that tight weave fabric should be used. Woven fabrics often resist cut better than the knit of equal weight. So, this is likely because the yarns in woven fabric are locked and present a firm target to the blade. So, this is a compact structure, they are locked structure, they actually present a firm target, firm structure. In knits the yarns can deform easily. So, knitting patterns also matter. So, adding tuck stitch or inlay yarns, that is a some yarn, strong yarn which reduces the mobility, significantly increases the cut resistance. So, we can change the cut resistance by changing the structure of fabric. Now, by layering or by increasing the thickness also we can manipulate the cut resistance. So, because due to increase in layering or increasing in thickness, more materials are coming into action, more materials will give more resistance. So, the multi-layer fabric or thicker weave will give better cut resistance, will be harder to cut. Okay. Because the blade must cut more number of fibers. Okay. And this is the straightforward assumptions, basis weight correlates with the cut resistance. So, for getting better cut resistance we must have thicker fabric, because and thicker fabric with higher mass per unit area, the blade has to cut more number of fibers. And type of fibers, although not exactly, the orientation, the nature of fiber, that the effect will be, the nature of fiber affects the cut resistance significantly, and also the orientation that we have already discussed, the steel, aramid, HPP, glass. So, type of fibers we can change to get the to manipulate the cut resistance depending on our requirement. Generally inorganic or high modulus organic fibers are tougher to cut than ordinary organic fibers. For example, aramid like Kevlar, ultra high molecular polyethylene like dynamite yarn give high cut resistance, whereas cotton, nylon of equal size would cut more easily. So, this is due to the polymeric structure we have already mentioned earlier. So, fiber properties hardness or toughness combined with the orientation determine the force. Like fibers of para-aramid or ultra high molecular weight polyethylene, they have higher hardness or toughness. So, they produce higher this cut resistance due to their high orientation. Now, the way the fibers are arranged in the yarn and also in the fabric, that also affect. So, the alignment, interlocking, ability to move can either be hindered or help the blade. So, that cut resistance can be manipulated by arranging the or manipulating the direction of the fiber. Optimal cut resistant textiles often use combination. So, we have to use different combination to get perfect cut resistant fabric. We have to use particular fiber, we have to manipulate the yarn structure, we have to manipulate the fabric structure to get the optimum cut resistance. So, strong fibers are used, oriented in multiple direction that we use, in a structure that does not easily yield or let the blade cut through. So, that different manipulation we can do in the fabric structure, yarn structure. So, after understanding the different factors, let us discuss the some smart cut protective fabrics. The latest frontier in cut resistant PPE is that integrating smart technologies, essentially adding a layer of intelligence and data protective fabric. So, that we can use in this smart cut protective textile, where we can incorporate conductive or sensor fibers with the traditional strength, like to create textiles that not only protect, but also detect and report the conditions. That we can do in some extreme condition, we can, it will be helpful. Several exciting developments are there. That is integrated conductive fibers for sensing. So, by weaving a conductive thread, manufacturers can turn the cut resistant gloves or sleeve into a sort of sensor grid. So, that different sensor manipulating the conductive threads with the non-conductive threads. So, different grid we can create. One application is in creating strain or pressure sensor within the gloves. So, how much pressure is applied or how much strain is being generated during the cutting process, that can also be detected. So, another approach is using the piezo-sensitive material within the gloves or within the any cut protective textile to actually map the pressure on our body like hand. For in a gloves, if we use the piezo sensitive or piezo resistive material, there we can map the pressure applied on the hand, that we can map. Then the sustainable and eco-friendly materials are also used. With increased awareness about the social and environmental responsibility, focus is being placed on development of eco-friendly cut resistance material. So, basically the cut resistant material after certain use, we have to discard that, and that should not be actually, the waste should not be dumped. We can use the recycling method to have our environmental responsibilities there. So, that recycled product we can try. So, recycling of aramid fibers are used, that we can use, and blends of organic cotton for eco-friendly or biodegradable and bio-based polymers are being explored. But main problem with organic cotton and bio-based polymers, here we cannot, normally we do not use in the case of cut protective textiles due to their inherent, they are not cut protective. Another step towards overcoming the pollution caused by the plastic is to use a natural fiber based composite we can use for manufacturing protective clothing. Again natural fiber based material, until it is urgent, it is required. We normally do not use the, in case of cut protective material. 3D printing and additive manufacturing can be explored. This is, we can use this. So, with the advent of 3D printing, it has enabled the mankind to create functional polymeric material which is reinforced with the metallic component for use in cut resistant textiles. So, that functional polymeric material with the reinforced metallic component we can use for cut resistance, that is additive manufacturing technique can be used. The studies have shown that commercially available 3D printed polymer with stainless steel reinforcement results improved cutting and abrasion resistance, that is being used here. The 3D printing also facilitates the manufacturing of cut resistant product by optimizing the structure and distribution of the material, resulting in better protective properties. Now, here we can see there is a frame with a fixed slot for reinforcement wear and stainless steel wear. The top view of metallic stainless steel reinforced inserted into polymer filaments during 3D printing. So, here in the during the 3D printing of the cut protective material, we can insert the stainless steel reinforcement which enhance the cut protection. the 3D printed polymer filament with metallic reinforcement. You can see that this is TPU 95A. This is one particular sample specification. This is the sample photograph is there, and macroscopic photograph. If we see here, here there is a metallic reinforcement we can see. Metallic reinforcement, it is very easily we can see. Fiber flex 30D, this is the fabric picture, and here we can also see the metallic reinforcement. So, 3D printed polymeric film is there, where the metallic reinforcement is there. This can directly be used for some cut protective application. These are commercially available material. There are other studies are there. You can see that 3D printed polymer here without reinforcement and with reinforcement. So, one is the fiber flex and another is TPU. With the reinforcement, the force required to cut has increased a lot. So, cutting force, cut resistance test is becoming very high, increased significantly, and here again fiber flex without reinforcement, with reinforcement, the here force per millimeter. So, with reinforcement in 3D printed polymer, if we reinforce with the metal, we can increase the tear strength and this cut resistance. So, both they are increasing. Now, this is the picture cross sectional of microstructure of fiber. So, without reinforcement, here it is a without reinforcement A, and this is the with reinforcement. We can see the reinforcement. If we see the cross section here, so this 3D printed polymer with reinforcement, that means the metal is inserted within the structure, which results much higher tear strength and cut resistant property. Now, one classic trade off is that comfort versus protection. In case of cut resistance textile, if we try to enhance the protection, then we must sacrifice some comfort. So, that trade off is very, we have to understand this trade off. So, comfort we cannot eliminate, we cannot overlook comfort entirely, because protection is important, but comfort at the same time is very important. So, generally stronger, more cut proof material tend to be stiffer, denser or less breathable. So, if it is stiffer, suppose one gloves is stiffer, so we cannot move, the wearer will not be able to move his fingers freely. So, that it will restrict the motion, and if it is heavier, then that it will enhance the load. So, it will be uncomfortable, and if it is breathable, it is not breathable, less breathable, then the moisture vapor from the body will not be transmitted easily. So, then it will give suffocation, and that is why the performance may be affected. So, innovations aim to mitigate these issues. So, we can have lightweight high cut protective textiles. So, that will help in mitigating all these problems, but the trade off still exists and must be thoughtfully balanced. We have to balance, we cannot sacrifice protection, but we can try to improve the comfort by sacrificing the protection little bit, by optimizing the protection. So, impact of higher cut level. So, if you try to use a textile with very high cut level, so achieving a higher cut rating often involves thicker and tougher material. As for example, adding a steel core, so that will enhance the cut resistance, but that will be actually restricting the body movement. Using a lower gauge knit or heavier coating, all these things will add to the mass of the fabric. Heavier coating will enhance the protection, but at the same time it will be heavier, and also the breathability will not be there. So, this can increase the fabric weight and reduce the flexibility. So, the particular material will be rigid. So, that will affect the body mobility. If a garment like glove, apron is too cumbersome, workers may remove it for any delicate task which defeats the purpose. So, if he altogether remove it, then it will defeat the purpose. Therefore, choosing optimum protection, appropriate protection, it is not simply maximum. So, optimum protection is that we cannot always try to select the maximum protection. We should actually choose the appropriate protection. So, which is important, because appropriate protection means with a significant sufficient comfort should be there. So, comfort is not just flexibility, it is also about the heat and moisture management. So, if we have lightweight, if its flexibility is there, it is not that we should also balance the heat and moisture. So, it should be breathable. So, thermophysiological comfort is also important. So, we can find many cut resistant material like aramid, glass fiber that are less breathable than the cotton and other natural material, and which can trap the heat. So, because less breathable means it will not allow the moisture vapor to be transferred from the if we are using the any apron. So, moisture vapor transmission will not be there, and so the heat will be trapped, because it will not take the heat, latent heat from the body. To combat this, manufacturer use the core sheath yarn knit structure that improve the airflow. So, core sheath yarns are used in the core, the high performance fiber like aramid or maybe the steel wires are used, but in sheath absorbing fibers, moisture absorbing fiber like cotton are used. For instance, some high cut resistant gloves like incorporate Coolmax or lyocell on the inner side to wick the sweat. So, inner layer will be this absorbing fibers like Coolmax or Lyocell, or use mesh zone at the back of the hand for ventilation. So, at the back of the hand some mesh zone is also used to create some ventilation. So, the proper designing of clothing is also important. So, coatings are applied strategically to leave the knit back open for breathability. So, in when we use coating, so we use coating for it is not for through entire garment where basic protection is required, high protection is required, there only we use the coating, but remaining portion we leave as it is, that knit or woven fabric if we use, and that is kept open for breathing, proper breathing or moisture vapor transmission should be there. Thinner high strength fibers like ultra high molecular polyethylene also have cool touch feel. So, to create the cut resistant fabric with better comfort characteristics, thermophysiological comfort or the sensorial comfort, we must take action, we have considered all this property, and also ergonomic design we have to consider here. So, engineers are applying the ergonomic principles to PPE design, sometimes called 3-dimensional hand model. So, ergonomic design they are trying to incorporate to ensure the gloves fit snugly and mimic natural hand curvature. So, the ergonomic design is people are doing by pre-carving the fingers and adding some fitting segments, a gloves can feel less bulky. So, these are the different ergonomic innovations are the design innovation. Some high cut gloves have anatomical thumb crotch design and tailored fingers. So, that despite thicker yarns the gloves bend with the hand more easily. So, again ergonomic design is there, that innovations are there. So, we can use a stretch material along with the high performance fiber like bit of spandex or elastic knit, they are incorporated strategically, okay, in a particular area where the threat is less, cut threat is less, to maintain snug fit without constriction. So, that it should not actually restrict our body movement. So, this type of fit, and also at the same time they are strategically placed. These features improve the control and reduce the effort needed to flex the glove. The comfort versus protection is important. This challenge is being made through better materials. So, here we can use better material which is a thin strong fiber. So, this if we use the thin or fine fiber which and strong fiber, in that case the this mass, weight and the flexibility can be improved, and at the same time the pore size, pore that very compact we may not required. So, where the breathability can be increased, and smarter construction we can use the plating, high gauge knit, different types of construction we can use, and user centric design we can incorporate. So, so that the comfort can be enhanced, keeping the protection level optimum, and also continuous feedback from the field, from the user. One has to get the continuous feedback and interactive design to have a better PP. So, the continuous feedback from the user, because we know this protection, we can test the protection, but feedback from the user, the what is the type of ergonomics, whether it is restricting the body. So, this type of feedback we should always try to get, and as compared to the older generation, and this offers the better design for protective textiles with equal and better comfort. So, we have overall discussed the different aspects of cut resistant textiles. We have discussed the different materials, different factors which affect the cut resistance, and also different types of standards we have discussed. And now we will start the case studies, and in this case studies where we have done our internal study, that different type of experimental study which have been published already, some of them we are doing. So, here we have developed different types of yarns, different types of fabrics, and different yarns means different types of yarn structure, and we will discuss how this yarn structures affect the cut resistance characteristics, and this we will be doing in the next class, next session. So, like mechanical performance of cut protective woven fabrics. So, where we have used the woven fabrics. So, our main study was focused on the woven fabrics which we have made with the core yarn. So, core sheath yarn, where metallic yarn, stainless steel or glass yarns were used in the core, and in sheath high performance fibers were used. So, this studies we will discuss in the next session. Till then, thank you.